And thanks for OWASP for great conference. I've attended some of the sessions. I actually had to pull a Hermione style magic to be on 2 sessions at the same time, which was interesting. I include a link. I did a snip link for the Slack channel in case you are not aware of it, and made it so it will be easy for people to write it down and join. This is a Slack channel for the Q&A. You can actually use it for the previous session also for now. And I'll try to jump right to the topic. So before we go into the autocorrelation project, I want to talk about IAST. Why did Appscan add IAST? So Appscan had dynamic analysis and static analysis for many, many years now, and we do strongly believe that there is room for both of them. Static analysis has some use cases that it has much better results, and dynamic analysis the same, but each one of them have the weaknesses. And we knew that we wanted to keep those 2 technologies. It wasn't about adding a technology to replace them. One of the values that the application security testing suites have, that those vendors, is that they give you a single pane of glass to see all the results. And to some degree, that single pane of glass allows you to do correlation. I can see this cross-site scripting coming from DAST on this page. I see it coming from SAST. I need to do some work, but potentially I can correlate those issues. Now, as I mentioned, we wanted to know if we want to add IAST. So we asked ourselves 2 questions. The first question is, can we give our customers and future customers more by adding IAST versus investing even more on DAST and SAST? Because as much as we believe we have strong capabilities, we can always do better. And the second question, if we go and add IAST, what can we do that for our customers that other vendors can't? There are very strong vendors in the market, like Contrast, like Synopsys, that have IAST already. What can we do better? So we thought a lot about it, and we felt that because of the knowledge that we have, the decades of knowledge that we have on dynamic analysis and static analysis, and our experience from 2011 when we added our own IAST, active IAST at the time, which didn't go that well, we felt that we can add more. We know that we can use those technologies to help us. So in order to do that, we started with the IAST. This session is not going to be about the IAST solution. It's going to be about the correlation project. The correlation project came from an idea that Ron had. We add IAST, we added support for Java and .NET and Node.js. And before adding the next language, Ron told me, I believe that we can do so much more by using correlation, and we can give so much more to our customers. So we started this research, and this is how we did. This was the intention. We didn't want to bring IAST again to replace DAST or SAST. We believe that each of them have strengths and each of them has weaknesses. So IAST, for example, passive IAST is relying on something else to integrate with the application, something to crawl it, to execute, whether it's manual or automatic, but you are dependent on having, for example, a good functional testing. IAST can be amazing for DevSecOps if you have functional testing because it offers zero-time analysis. Static analysis has the best coverage probably, but it's known to be noisy and require developers. As much as we apply machine learnings and different techniques, it requires developers or security experts to triage hundreds or thousands or sometimes even tens and hundreds of thousands findings in order to find what to fix. And DAST has the strength of having, again, like IAST, very high confidentiality, high accuracy levels, but the DAST won't give the developer what they need in order to fix the issue. It will give them reproducible scenario, it will give them high confidence in that, but not how to fix or where to fix. So we wanted to look at this as how can we add IAST to the mix and benefit from it on top of the others, to how to use it to strengthen to enhance the strength of each of the technologies, and also to mitigate the weaknesses from them. Adding IAST wasn't supposed to replace. I'll mention that too several times. It's not supposed to replace anything here. It's just supposed to enhance and to get really the best of all worlds here. In order to do that, we took an easy way to start, and we look at the OWASP benchmark. I'm sure that most people here know OWASP benchmark. It's a very good, very strong project that OWASP runs. in order to do a bake-off between different technologies, between different tools. It has over 1,700 vulnerabilities in it, in that vulnerable application. And it comes with a true set, and it comes with scripts to run the application. So in order, as I mentioned, in order to test, to use passive IaaS like we have today, you need something else to interact with the application. So the project comes with scripts that execute all parts of the code, all parts that will result in vulnerabilities. We'll find them. The application contains that true set. We know exactly what are the 1,700 and something vulnerabilities, so it makes it easier for us to base the correlation on it. And we know that with our solution, we get 100% score on it. We find all the vulnerabilities and we don't report any false positive. Before we went into that, we also acknowledge the fact that OWASP benchmark is a bake-off application. It's a testing application, and it's meant to test technologies. And it's meant to show the weaknesses and strengths of each technologies. So it's not easy for every IaaS solution to get to 100%, and some do, but it's definitely hard or even impossible for static analysis or dynamic analysis tools to get to that, even when you apply very advanced configurations to the tool. Our goal was to bridge that gap, to understand that SAST won't find everything, that DAST won't find everything, and there will be false positives and false negatives, and how with adding IaaS, we will be able to get to that. So the steps, and I will explain the process, and then Ron will take over and talk about the results. The step that we took, we tested it with IaaS based on the script. So we had our agent monitoring the application, and we ran all the scripts, and we put that on the side. And then we ran a static analysis scan on the code, completely unrelated. And we ran a dynamic analysis, again, without the IaaS agent. So at a different time, we didn't want the DAST to benefit from any insight that IaaS can share with it. And we didn't want IaaS to benefit from any crawling that the DAST did. We completely separated them intentionally. The next thing that we did, we ran all those scans with the basic and naive configuration. And it is important to mention that because you will see later in the results that DAST and SAST didn't score that high. We could score higher, but we wanted to test the basic and naive configuration in order to measure what IaaS can add to those technologies when you don't configure them to the extreme. The goal was to overcome those false positives that we had with the different technologies, and to see if the autocorrelation can replace the advanced capabilities, the advanced configurations that we could use with the tools. Again, default configuration only. Next step, we saw that with IaaS, we can indeed identify all the issues with 0 false positives. Running static analysis with the default configuration, we found over 5,000 issues, which is 3 times more than what we found with IaaS. We didn't go and validate any of them at this point. Running DAST scan, we found a little bit over 600 issues. So again, I want to state it again. Those are default configurations. Some other tools can get better results, and they will tell you that. We can get better results also with AppScan, but that wasn't the intention. After explaining all the process, Ron, I'm passing it to you.
Yeah, I'm trying to request remote. Let me know when you see the...
I suggest you give up. I'll run the slides.
Okay, so after we cover the process, we can start talking about the result that we saw. So after running the correlation algorithm on IaaS and SAST, we were able to actually match 21% of the SAST issues with IaaS issues. So as Eitan mentioned before, we knew coming into those results that we'll get a lot of noise from SAST. We'll see a lot of issues being triggered, and we wanted to bridge that gap and allow the customer or allow customers to actually have a data-driven way to prioritize the remediation process. So after taking a look at those 21%, we were really happy to see that those 21% are actually 66% out of the true set. So I'm really comfortable saying that prioritizing those issues first will be very data-driven and will create great results. Now, on top of that, the correlation actually gave SAST a little bit of a power-up. So up until now, when you resolve a SAST issue, you need to trust your developers and security champions, whoever is actually approving the fix, that the fix is valid. After marking this vulnerability as fixed, there is nothing that SAST can do in order to locate or identify it again. But when you have a correlation between a SAST issue to an IAST issue, all that you need to do is apply your fix, initiate the same interaction, and see if IAST is triggered again over the same vulnerability. So not only you have a much better way to prioritize your efforts, you also have another capability that wasn't available before that. For correlating IAST and DAST, we were actually able to match almost every DAST issue with IAST issues. So again, as Eitan mentioned before, when a developer is using DAST to resolve an issue, all he have in order to resolve or remediate this vulnerability is the request and the response, or the lack of response that he gets from the DAST report. Now, adding everything that you have from IAST actually provides everything that the developer could ever wish for when resolving this issue. You get all the information from source to sink. You get to see all the parameters, the call stack is available to you. If you're using our solution, you get an exploit example. So essentially, everything that you need to have in order to remediate the issue is now available to you. And that's something that we heard a lot. I mean, that was the original intention going into that project.
I just want to mention something before anyone get the wrong impression. We're not suggesting that you don't need DAST here, because almost everything that was found with DAST was found with IAST. We acknowledge the fact that we're using an application that we get 100% score with IAST, and we don't, modestly, we don't expect to have 100% of accuracy in real life applications. So the diagram is great for the chart, but remember, this is on the OWASP benchmark. We are sure that the diagrams, well, we know that the diagrams look different on other applications.
Yeah, absolutely. So after going about IAST DAST and IAST SAST, we've taken a deep dive into IAST DAST and SAST. And obviously, everything that I said up until now is still applicable. And honestly, if you have correlation on your project, I would rather suggest that you will start with the IAST DAST and SAST correlation. But something that was really clear, or really like popping out from the report when looking at this group, is something that was a little bit counterintuitive, to me at least, coming into this project. So when I thought of a complicated or a robust correlation, I thought that the ratio between IAST DAST and DAST will be at most 1. So the biggest correlation group will have a single IAST, a single DAST, and a single SAST issue. And after taking a look at this group, we thought that this is rarely the case, and this is really uncommon. Like, we saw a lot of groups being correlated with even 8 or like multiple number of DAST issues, multiple number of SAST issues. And I'm going to explain a little bit how it looks like. And after doing some research, it was actually kind of very obvious why it happens. So let's say that I have a simple application, and this simple application contains 2 REST APIs. Those RESTful APIs are exposed to the user outside of using the application. And each of those have a different propagator or data flow before they take the user input and use it in an SQL query. But those 2 different and 2 separate RESTful APIs use the same sanitizer. And let's just say that that sanitizer, in this example, obviously hoping that there is a sanitization process along the way, which is also not something that we should take for granted. Let's say that this specific sanitizer isn't very effective for SQL injections. From DAST point of view, DAST will have to report two separate SQL injections, one for each RESTful API. And again, we are taking a look at this application, but this flow can be much more complicated or robust or even simplified because APIs can use each other. What we have when we pull the curtain and let IaaS take a look behind the server side, we can locate those weak links and actually correlate separate SQL injections that are caused by the same weak link in the development flow. Now, something that I really need to emphasize, again, we are working in this specific example on a benchmark application. And a benchmark application tends to be developed in a certain way. But when we're testing those capabilities on actual real application, we can actually see this kind of behavior more than often. And that's kind of like self-explanatory. Code reusage is one of the cornerstone of best practices in software development. So using the same sanitizer over and over again is a best practice, as long as that sanitizer works for you. Now, on the right here, we have an example from a different project. We run the same correlation project on the WebGoat application, and we can see a correlation that we're able to do on 8 different vulnerabilities. Now, we can see that IaaS and SAST detected this group as an SQL injection. But when we take a look at the issues we found on DAST, we can see that the first one is a blind SQL injection, which makes sense when you think about how DAST look at the application. But the more interesting issue that we found was the application error. So yes, that's just an informational issue that we reported. But the idea behind that and the fact that we are not coupling the heuristics of the correlation with the issue types allow us actually to create those groups of multiple vulnerabilities that are caused by the same weak link in the code. So that's also a really nice example that I personally like. And obviously, one of the reasons that we're able to, I can say, compress and consolidate multiple issues into a single one.
I think it's interesting for those of you who watched the keynote that Chris did. He was talking about customers that are adding DAST and SAST, and with that, they shortened the time to fix by 24 and a half days. Imagine what value that they can get from the correlation. We save a lot of the time on triaging. We save a lot of the time on prioritizing from the triaging and giving all the information that they need. Now, he said something very clever, very important, that the industry moves. The industry now focus on fixing the issue and not just detecting the issues. He made a point where customers will say, "Had the technology just means that I have more to fix." When you use just SAST and then you add DAST. But what we show here that we have SAST, we have DAST. Before that, we had those 2 issues in DAST, this issue in SAST, and we added IaaS. We actually took 80 issues and made it 1. So we reduced the amount of issues. And in the next slide, Ron will talk more about that.
Great way to steal my thunder. So what we have here is actually a screenshot of the top of the report that we created. Up until now, I talked in percentages, but now you can actually see the numbers that we were able to identify. You can see the number of issues we found using IaaS, DAST, and SAST. You can see how many of those we were able to correlate. And you can see, and that's something that I really like about this table, the amount of issues that are still left after the consolidation process. So even though, for example, IAST started with 1,723 issues, by the end of this process, we're able to reduce this number to by about 200, 300 issues. When we just started this project, I thought that the best value proposition I can offer using correlation would be to have a data-driven way of prioritizing issues, saying, you know, just run correlation and then start working on the issues on the intersections. First of all, solve the 361 issues that we found using IAST, DAST, and SAST, and after they go to IAST, DAST, IAST, SAST, and from there, wherever you feel more comfortable. But what I really like about those numbers, and again, those numbers are even lower than the one that we get when we actually use real live applications. But if you take a close look into any of those intersections, you will see that the total amount of issues after consolidation is lower from each of the other total issues in the group. So not only you get all the benefits that we talked about, like additional information, the ability to retest fixes for SAST issues, by just adding IAST and running a correlation, you are actually going to reduce the amount of work that you have to resolve. And obviously, you're going to reduce the amount of effort since you are more data-driven on your prioritization, and you are more data-driven when remediating the issue. You have much more information and much more utilities that can assist you with the process.
So just to emphasize it again, if we look at actual numbers, we had just for those between IAST and DAST, for example. You ran DAST, you got 121 issues, and now the developers and the security team needs to go and triage those 121 issues. If someone did the effort of adding IAST agent, then one-time effort to add it to the application, that 121 turned into 89. So you reduced 32 issues, and that's 25% of the issues that the tool reported for you. On static analysis, we didn't see the same percentages, but again, we do know it's skewed by the type of the application that we used in this research. So, and on the other hand, also, if we are looking just at IAST on its own we were able to consolidate issues because of the way that we do the correlation today. So this is what we had to share. We have our details here. Again, the Slack channel, if you have more questions to ask us. And if you are watching the recording, by the way, the Slack channels will still be available. So you can post questions there. Lon and I will try to monitor them, but always feel free to either direct message us or connect with us over LinkedIn or Twitter. And we have the details here, or send us an email if you're more old fashioned. So thanks. Thank you all for listening. I hope that you got value from it. We're about to go to break. And I hope I'm not stealing your thunder now.